Pydantic AI's mechanism for injecting dynamic behavior into an agent through a capability that resolves at runtime based on user context, operates here via a single custom, skill, class, and a factory function wired into the agent's capabilities parameter, with deps type equals SDR, constraining the dependency shape that RunContext then exposes. The visible code demonstrates registering a callable capability that selects a per-user skill from a dictionary keyed by CTX. Deps, constructing an agent with that factory, and executing a run with deps equals Alice to surface the resolved instructions in the first message. From data classes, import data class. From typing, import literal. From Pydantic AI, import agent, RunContext. From Pydantic AI, capabilities, import AbstractCapability. From Pydantic AI models, test, import test model. At data class, class skill AbstractCapability SDR. Per user skill, loaded from a database at runtime. Name, SDR. Role, literal admin, guest. Def get instruction self, SDR. Return FU can use the self name skill role, self role. Hash pretend this comes from a database keyed by user. Skills equals Alice, skill name equals refunds, role equals admin. Bob, skill name equals lookup, role equals guest. Def user skill text. RunContext SDR, AbstractCapability SDR, none. Return skills, getText.deps. Agent equals agent test model. Deps type equals SDR. Capabilities equals user skill. Result equals agent. Run synci, deps equals Alice. Print result, all messages 0, instructions. You can use the refund skill role, admin. This is dynamic capability resolution via a factory function. The user skill function receives RunContext SDR, reads CTX, deps, the dependency passed at runtime, and returns a preloaded skill instance from the skills mapping. The agent is constructed with deps type equals SDR and capabilities equals user skill, so each run resolves a different capability based on which dependency is supplied. The skill class subclasses AbstractCapability and contributes instructions through getInstructions, which the agent then includes in its instructions to the model. The pattern avoids constructing separate agent instances per user. Instead, you resolve the right capability at runtime, which means one agent definition serves multiple user contexts. The trade-off is that the capability is resolved dynamically, so the agent has no static knowledge of which instructions or tools it will receive. It depends on the factory function and the dependency value. In production, this works well when capability data lives in a database or external source keyed by user. But you need to handle the none case, since not every user will have a skill assigned. The framework composes the returned capability into the agent's existing capability stack via combined capability, following middleware semantics, so the dynamically resolved skills instructions, hooks, and tools flow through normally. This is the intended pattern for per-run variation that depends on runtime context rather than agent construction. Let's break it down. From data classes, import data class. From typing, import literal. Imports data class for defining data classes and literal for type-level literal values. Def user skill text. RunContext SDR, AbstractCapability SDR, none. Return skills, getText.deps. Defines a function that retrieves a capability from the skills dictionary using the runtime dependency instance as the key, returning none if no match exists. Agent equals agent test model. Deps type equals SDR. Capabilities equals user skill. Creates an agent instance with test model as the dependency instance. Declares SDR as the dependency type for type checking and attaches user skill as a capability.
Result equals agent. RunContext.deps equals Alice.
Calls the agent's synchronous run method with the message, hi, and passes an object named Alice as the runtime dependency. The call blocks until the agent completes and returns a run result.
Print result, all messages 0, instructions. You can use the refunds skill role, admin.
Accesses the first message from a run's message history via all messages, extracts its instructions field, and prints them. The output is a single instruction string granting admin role access to the refunds skill. One agent, one capability factory, multiple users. The deps type equals SDR plus capabilities equals user skill wiring means each run resolves a different skill via CTX. Deps, and that resolved skill's instructions flow through the agent's capability stack as if it had been there all along. The trade-off is real. The agent has no static knowledge of what it'll get, so you handle none and accept that the behavior is runtime bound. But you skip the cost of spinning up separate agent instances per user, which is the whole point of this pattern.
Deps pours through RunContext. A skill holds name and role before the agent ever runs.